and we're integrating from -8 to -1. Okay, let's see. The next step, we just got to clean this up a little bit. So if I have divide by 5/3 the same as multiplying by 3/5, so I end up with 3/10 x to the 5/3 minus divide by 8/3 same as multiplying by 3/8, so it'd be 3/16 x to the 8/3, evaluating from -8 to -1. Now what we're going to do is take f of -8 minus f of -1. That's a capital again. So let's see. 3/10. 3/10. This will be -8 to the 5/3 power minus, now here's the tendency. Here's where you have to be really careful what you're doing. The tendency is to want to now say 3/16 -1. Okay, you can't do that because what we're doing is putting -8 in this entire antiderivative. And so we have to say -3/16 -8 to the 8/3 power minus, and now go through the whole function, antiderivative function, with -1. So it's 3/10 -1 to the 5/3 minus 3/16 -1 to the 8/3. And from here on out, it's just arithmetic, okay? But that's where we can get tripped up. So make sure that when you do this work, that you are also checking your work. You can have everything perfect down to this point, and then we all trip up on arithmetic, okay? So 1/3 power. Becca, what's another way of saying 1/3 power? Yeah, what's the cube root of -8? Be -2, because it's the cube root. Okay, so we've got 3/10 times -2 to the 5th power minus 3/16 -2 to the 8th power. Cube root of -1? -1. So we have 3/10 -1 to the 5th power minus 3/16 -1 to the 8th power. Put that down farther there. Okay. And again, it's just the arithmetic that's, if you make any mistakes at all, I'm going to make them too, so I just have to be careful. But if we check our work, we should know if we're correct or not. -2 to the 5th power. Is it going to be positive or negative? It's going to be negative. -2 to the 5th power, anyone happen to know what that is? -32. So we've got 3/10 times -32 minus 3/16. Now I don't know what the 8th power of 2 is. 2, yeah. Is it positive or negative? Positive 256. Do you have that memorized? You just worked on it. Okay. And this is going to be a little easier. -1 to the 5th power is still -1, so that's -3/10. -1 to the 8th power is going to be positive, so that'll be -3/16. Again, just trying to be as careful as you can with those fractions and everything. Finding out some ways you can do that. I'm just going to say ... The answer comes up to be, if you want to look at a fraction, is 4569 divided by 80. Emma's going to check to make sure that that's correct. That's approximately 57.1125 square units. Okay. And if you look at this, I'm not going to take the time to do that, but there's the function, and there's the value, negative 57. Oh, where'd the negative go? This says negative 57. Okay. So where did we mess up? Because I don't have a negative on mine. So negative, negative. But I'm taking the opposite of it. So that'll be smaller. Okay. Yes, Chelsea. That's why, you know, and this is why I was looking at. I'm thinking it should be positive, and you're right. Okay, we're going to come back and correct that. I was looking at this thinking, why does that, we got to do this, because didn't we say that if it's above the curve, it should be positive quantity? Okay, and this looks to be above the curve. Now, remember also there was the property that said, if you integrate, and it was back in section 5.2, but if you integrate from A to B, it's the opposite of going from B to A. Remember that one? So, you're absolutely correct. I did what a lot of you will probably do too. Isn't negative 8 greater than negative 1? Absolute value-wise, the answer is yes, but in actual numbers, no. So in order to correct this without correcting all of the work, what could I do? I'm not going to even switch them around. I don't want to erase all this. But didn't we say that if we integrate the other direction, it's the opposite of integrating in the correct one? Are you okay with that, Chelsea? Okay, Erica, do you have a comment?
No.
Okay. Yeah, it should be, since actually, I did that. That should not. I did one too many on that. There we go. It's the negative over here, and so if I go down one, I should put it on this one, since I did in fact integrate the wrong way. And again, would we pick that up from our work? We should, in that, if it's above the curve, it should be positive, and if it's below the curve, it should be negative. I'm going to make that just a positive there. So this really should be a positive on here, and I can only guess that if I did this again, if I go from here to here, it would be a positive. Anyone checking this for me? We probably need to. I don't want to take time today, but we could check that to make sure. But it's above the curve. Yes.
You said that we don't have to ask the other companies.
Yes. 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 And I'll take a look to see, because I was thinking there was a way without that analyzed graph that we could do that. And so I've got to just go back and find what I was thinking, and if it is another activity that I need to send you, then I could send that to you, and you could use that then too. Okay. Okay. Well, let's see. This is just looking at some examples. Another example here to go through. We're going to take care of these on Thursday, find the area bound. What I am really wanting to get to is this mean value theorem for integrals. And we'll take care of this. This is what I'm heading for on Thursday. I want to make sure we cover this on Thursday. There's the mean value theorem, and then there's the definition for average function. And we'll take a look at those. So that's what our main idea on Thursday is going to be. Will be those ideas. Anyone verifying this last one? Okay. And so while if you're going to work on it, we'll just take your work. Find what this button on this pen. I tap and I don't mean to. There we go. Okay, so it's Emma who's working on it. Okay.
I couldn't get it right after the video before I stopped in my way, but I got to 59, but
Okay. And it is positive if we go the correct direction. Okay, very good. Any questions? We got 5 minutes, but any questions? Oh, thank you. That's a good question. Because I tend to forget to do that. Okay, so we'll do that right